Everyone, this is Shauna coming to you this week with your tutor check-in. This week in Math 112, we'll be working on Chapter 5. It's a different kind of distribution. We're going to be talking about discrete random variables. This is something that we haven't focused as much on. Remember, discrete variables are variables defined by countable objects. So it could be the number of people in a PTA meeting. It could be the number of patients in a hospital. It could be the number of birds in a tree. Those are discrete variables. It could be the number of aces in a standard deck of cards, something like that, or the number of kings that you draw from a certain deck. Could be something like that. And this chapter focuses on discrete random variables and their distributions. So let me show you at this time. I need to open the file first. So the first topic that we're going to be discussing, appropriately enough, is probability distributions. And these particular characteristics are going to look very familiar to you because they're the same characteristics that you learned when you were studying probability in chapter 4, but we're going to apply them to probability distributions. So let me show you that at this time. I'm going to close a couple of windows because I have a little bit too much activity going on and I really don't want my internet to become unstable right now. So we start with discrete variables, assume values that can be counted, and continuous variables have an infinite number of possible values that can be represented. And we also start with the discrete probability distribution consists of the values the random variable can assume and the corresponding probabilities of those values. So one of the things that you're going to focus on in this section is identifying whether probability distributions are true or not. And so we have these two properties which look very familiar from chapter 4. The sum of all the probabilities of all the events in the sample space must equal 1, and the probability of each event in the sample space must be between or equal to 0 or 1. So 0 means an event is impossible. 1 means an event is certain, but most probabilities are between the two. And then we have some examples that display this. So determine whether the distribution represents a discrete probability distribution. You want to look to see, are all of my probabilities between 0 and 1? Yes, they are. And do they all, when you add them all together, do they add up to 1? Well, 1/7 plus 1/7 is 2/7. 2/7 plus 3/7 is 5/7, and 5/7 plus 2/7 is 7/7 or 1. So yes, this is a discrete probability distribution. And then we have examples for you to follow. If you look at the second example here, the problem here, among others, is the probability of 20 is 1.1, and you can't have a probability that's larger than 1. So this is not a probability distribution. Now, the fact that you're looking at discrete probability distributions is important because they have certain properties. And we're going to be coming back to some of the stuff that you did in chapter 4 with this, with drawing tree diagrams and finding probability distributions. But that's about all you're going to be doing in the first part of the chapter, is learning about the properties, learning to identify them, and learning to graph them accordingly. Now, moving on, let me stop sharing this screen here. And let me start sharing, whoops, wrong screen, sorry guys. I'm going to pick up the next section here and start sharing 5.2, which is going to tell us a little more about certain calculations. And this might be something that confuses you a bit, because now we have more than one formula for some of these things. So I want to go over that briefly. We're going to be talking about the mean, the variance, the standard deviation, and expectation, which you're going to see on the screen next. And we have the mean, the variance, the standard deviation, and the expectation. Now, this is not the same form of calculation that you were doing in chapter 2. In chapter 2, we were dealing with continuous variables, and we had other forms of, we had raw data. We were doing raw data in some cases. In some cases, we were doing group distributions. This is a discrete distribution, a discrete random variable. So the formulas are different here. So beginning in this chapter, you need to start comparing the types of distributions, whether you have a continuous distribution, whether you have a discrete random variable, and a lot of times they'll be stated, but you can also tell from the kinds of data that you have. So let's take a look at these formulas here. Now, if you're doing the mean, we have this funky notation. This is sigma x times p of x. So you're going to multiply the value by its probability and add them all up to get the mean. The variance, you're going to square each value, multiply it by the probability, add up all of those products, and subtract the square of the mean. So you have to find the mean first. And the standard deviation is the square root of the variance. So there is an example here for you. She laid out the data, and then she gives you the calculation of what I just showed you in general, okay? And that's predominantly what this focuses on. The other concept that's in here is the concept of expectation. And this is a little bit tricky. So expectation is basically the mean of a probability distribution, but when we talk about expectation, it's usually in the context of gambling. So you buy a certain number of tickets for a certain price, and then you have a certain probability of winning, and you have a certain probability of losing. What is your expected return if the game is played out to the fullest extent? This is a little bit of a tricky concept. So I don't want to go into a great deal of detail here. You have the videos, you have the textbook, you have the PowerPoints. please use those. But if you have trouble in the section, let me know. And if a separate video is warranted, just like I did on section 4.4 and some of the problems in 4.4 and 4.5, then I'll do a separate video on expectation. But I want to see how you do with the material. If you'd like a separate video on it, you can let me know. You can message me via the Canvas inbox. But essentially, that's what 5.2 is about. So we've learned about discrete random variables. We know what discrete probability distributions are. We know how to recognize them. We know how to graph them. We know how to find the mean, the variance, the standard deviation, and we know how to find the expectation. Now, the last part of this deals with another type of distribution, which is also a discrete distribution called a binomial distribution. And a binomial distribution is special because you either have only two outcomes or you can reduce all the outcomes in the sample space to only two, namely success and failure. So basically, this is a very kind of black and white in that sense distribution. And we have the common phrases at the top of the picture. We also have the binomial distribution or the binomial experiment. Now, these properties are very, very important. So these properties you want to memorize, you want to study. They're not that hard to understand, but you will be tested on these properties in one way or another. We most likely will not ask you to write them out, but you do need to know what they are because they're going to occur in all, and you have to know the difference between a binomial distribution and other forms of distribution. So we talk about distinguishing those. We also talk about notation for a binomial distribution. And there's something that I want to point out here. When you get to binomial distributions, we have, as I mentioned, two outcomes, success or failure. Success is not always something good. Sometimes a researcher is looking for the instances of people who are sick. That's not necessarily a desirable outcome, but maybe he needs to find them in order to treat them. Success is finding what you want to find or finding what you expect to find. For example, there's a problem in the textbook that says something like, there's a man, he goes out into the woods and he's a tree surgeon, and 20% of the trees in the forest are infected. If he samples 10 trees, find the probability that at least 3 are infected. Now, in his case, he's looking for the infected trees. So even though it's not good to have a tree that's infected, that's sick, he's looking for the trees that are infected. So in his case, that's a success. So don't get caught up when you're reading this section into thinking that success means a desirable outcome. It doesn't always mean it's what the researcher wants in that sense, but it's not necessarily a positive outcome. And by the same token, failure is not necessarily negative. Be careful with that. We have the binomial probability formula and have a bunch of examples that help you with that. We also have some calculator instructions. Some of you mentioned that you need help with your calculator. Most of the time, any calculator instructions that you need will be given to you in the slides, but I do have supplemental material if you need extra calculator instructions. Now, the other thing that I wanted to bring up here is notice here that these formulas, the mean, the variance, and the standard deviation, are different than the ones I showed you in 5.2. Why is that? The slides in 5.2 that deal with the mean, the variance, and the standard deviation were for random probability distributions, not for binomial, okay? So again, you'll know from the data, you'll know from the setup. Sometimes you'll know from the way the problem is written, but you have to be able to distinguish that because the formulas are different. So do know that they're different. Do be able to distinguish a random probability of a discrete random variable or a random probability distribution from a binomial distribution, okay? And there are slides and exercises to help you practice. That's about it for the review for this week. Hope that gives you a little bit of a sense of what you're going to be doing with the material. Hope that helps give you a feel of what the material is going to be like. Come back to this video as you're working through it. Do ask us questions, and I'm going to tell you the same thing that I told the other class. Please, when you send us questions, a specific question, even if you don't know what to ask us, is more helpful than a random, I need help kind of question. It's fine to say, I'm lost, I don't know what to do. But if you tell us, okay, I was doing section 5.2, number 17, and I got this far and I didn't understand this, it's a little better because it helps us understand how you think about the material, and it helps us respond more directly to what you might be having difficulty with. If you have work available, screenshot your work, take a picture of your work, send it to us. We're not grading you on the questions that you submit. We're more than happy to answer your questions, but help us help you by being a little more specific and providing us a little bit of context, okay? Take care, everyone. Hope you're doing well. Keep working hard, and I'll talk to you in the next video. Bye for now.